Welcome back to the channel, everyone. Today we're going to be going over Foundry for gaming. We're going to look at the architecture of the system, and we're also going to hear from the founders of the game plumbing framework, Iman and Daniel, who created this awesome framework that makes this sort of thing dead simple. It's primarily through their use of what they call server authoritative objects, and they can drive lots of behaviors from the server in the game, not the least of which is streaming telemetry data. So that's what we're going to be working on today. We're going to figure out how we can stream telemetry data that lets us power A/B testing and also alert us about issues in our game server. We're going to talk a little bit, I'm going to do a full interview with the founders, and they're going to talk a lot about their past experience doing things like A/B testing at Disney for Disney games and how valuable that data is. And we're going to talk about SDK overload and why it sucks today to have to integrate all these various analytics, telemetry data SDKs into your games and into your apps. We're also going to talk about the engineering alerts and telemetry data that's really important to monitor there, so you can see the health of the game server, making sure that your users aren't getting a degraded experience. And all of this can be powered by Foundry. You don't need another SDK. You don't need another analytics engine. You can totally own all of your data first party. No one touches it with Foundry. So get ready, people, for Foundry for gaming. All right, so let's go over the architecture real quick that we're going to be building. It's actually really simple. As people play the game, there'll be events streaming from the client, as people play the game, they'll be interacting with the gaming server, which is a Fargate cluster on AWS. Those interactions go through an internet gateway, through a load balancer, and finally into the game plumbing framework server objects and full stack here. And they will then stream telemetry data from the server, making sure to sanitize data, validate events, all of that kind of great stuff. They'll send it back out through the NAT gateway, which is basically just a gateway that says you're allowed to communicate with this internet resource, which is the API I've created to take in the telemetry data from the game plumbing framework. Goes back out through the internet gateway and over here into Amazon's API gateway, which is the one I created with the serverless cloud and is hosted in the serverless cloud's VPC. And my Lambda function will process it. It gets stored in DynamoDB. Again, I didn't configure any of this. This is all abstracted away from me by the serverless cloud. Thank you very much. Thank you, Jeremy Daly, and the whole team. And then eventually what will happen is we've set up our sync in Foundry that will go and initiate a job to go get more of these events. It'll go through a NAT gateway, back through an internet gateway, over to my API, and query it for new data. And that data will get ingested in Foundry and then processed through our data pipelines and eventually wind up in our ontology layer. So this is the general architecture. We're in a single AWS region, so this isn't like a multi-region deployment. We're probably running in, I think the game plumbing framework is deployed in one AZ, and then the service cloud, I'm not exactly sure. There are probably 3 AZs in the same region. An AZ, for people who don't know, that's an availability zone. You can think of an availability zone as a separate data center within an AWS region. So the more availability zones you deploy to in an AWS region, the more redundancy and durability your application is going to have. But for this, we don't really care. It's just a POC. If I was running in production, I would definitely be concerned about redundancy and setting this up so that it had high availability. For people who don't know what high availability is, that's the measure of how much downtime your system has. And so generally speaking, when you're looking for production apps, you want like at least 99.99% available apps, and that's, you would probably go higher than that in a lot of cases, or try to. So anyway, this is the setup for this one, and again, non-production, but this would actually be super easy in my opinion to deploy at production scale, although I think the main challenge would be Foundry and what kind of cost structure you'd be looking at if you want redundancy there. I haven't talked to them about that sort of thing yet, but I'm sure they offer packages where you'll have plenty of system redundancy if you can afford it. Anyway, this is the basic architecture. All right, so what is the game plumbing framework? Well, the game plumbing framework was created by a friend of mine, Iman, and this other gentleman, Daniel. and it's meant to essentially provide you with a server authoritative framework for designing games. And it's available now. You can check it out. I'll leave links in the description. It's super easy to get using and to interpret. The code is super, super clean, and they did an excellent job. You can really tell this is the culmination of a lot of years of experience by two very, very talented developers, and I can't wait to see what people build with it. But to learn more about the game plumbing framework, I'm going to jump into an interview I did with the founders, and you're all going to get to learn a little bit about why they created this framework, the advantages it has, and how it's going to integrate with Foundry to solve the analytics problem, which is a huge problem not only in gaming, but in a lot of various aspects of application development. And with that, let's jump into the interview. We are live. Welcome back to the channel, everyone. Today I have some special guests, and I actually have a microphone. You guys have been asking for it, so I've got a microphone on my channel for the first time ever. But I want to introduce our guests today. This is Iman and Daniel, creators of the Game Plumbing Framework. And Iman and I go way back. We used to work together about a decade ago or more now. I can't even remember. It was a long time ago. But yeah, good to have you guys here.
Great to
Thanks.
be here, Dorian. Wonderful channel, by the way. Congrats on all the success. Yeah.
Thanks. So Daniel, how'd you meet Iman? Like, because I mean, I know where he's from. We kind of go way back in history. But how'd you hook up with Iman?
So Iman actually hired me.
Oh, no way.
Yeah, he was working at a really cool company that was in the educational app space.
Yep.
Um, and I was the first person he hired at that company. And we had instant programming chemistry. We almost immediately, shipped a really cool app, and we kind of kept the momentum rolling after that. We always had our eyes on shipping, quality, and making sure that the 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 company was functioning and producing
Yep.
apps at a
Yep.
great rate with great quality and that kind of stuff.
I
So
often
we
find that
really
in
connected on
founders.
that.
Yep. I find that in founders a lot. Like they have like a chemistry, and like
Hmm.
just like when you actually hook up with someone who you enjoy working with, you can get some really cool stuff done, which is really
Mhm.
awesome.
Yeah.
Cool. So Iman, like, how long have you guys been working on the framework, and can you tell us a little bit about like how it evolved, or?
Yeah. So I would start us at about maybe 3.5 years ago. Basically, I have a ton of gaming experience. Technical director at Disney, worked with Dan, had my own startup that did lifetime value for games, and I kind of went in a different direction, and I was doing AI stuff. Um, you know, uh, basically. Computer vision, and I kept getting called back to the game space because these really big companies were having problems they couldn't solve. How do you do a multiplayer map that's like infinitely scalable? And I thought that was interesting because I kind of left games because I felt like they were all like we had a bunch of solved problems. But what I saw was what was happening in games was there was this bigger need for connectivity, multiplayer, and that had caused this like massive bottleneck on how do we get engineers to actually build these systems, because game engineers traditionally are very good at building fun, and then you have these other types of engineers, they're infrastructure guys. Maybe they have like PHP backgrounds, but they don't know about games, right? So to get like a
Yeah.
back end game engineer, that was a rare breed. So as I was doing these projects, I kind of saw these like common patterns, and I came up with this idea called the server object, which I basically borrowed from like an actor system.
Yep.
But it was how do we take it all the way to the client and make it really simple and automatically persist and automatically keep things in sync. And I said, okay, if we can nail this server object idea, then it would make everything else so much easier, because now all of a sudden all those game engineers that are good at building fun get to not have to worry about infrastructure. And I think we can pull it off. And I was really naive. So I showed what I was working on to Dan. And coincidentally, Dan was working on a reactive front end
Nice.
framework. And I'm
Nice.
like, look, my stuff and your stuff, like, correlate perfectly. One of my big problems was Dan is like 10 times better at Unity development than I am, and I didn't want to mess with that side. So
Yep.
we just started coordinating. Like, we could have our two projects, and they'll know about each other. And then eventually it was like we could do so much better, build such better software, and be such a more powerful interface if these things were very tightly coupled, and it was kind of this one thing that had these three parts instead of
Nice.
this, like, different parts. So the motivation was really about how to build better software.
Yep.
And initially we were like, hey, we can build this thing in 6 weeks, and we'll have something to show the next GDC. And
Cool.
that was super naive. So that GDC got canceled, and the next one got canceled because of COVID. And it turned out we were right. We actually were ready by the next GDC, but that was more because of COVID
You were technically right, I guess.
yeah.
You were like breaking down. So like Dan, let me jump back to Dan real quick. What were you working on in gaming prior to this? And then with reactive data in gaming, can you talk a little bit about the role reactive data plays in games and sort of the problem space you were in before you were working with Iman?
Yeah, so I've always been into gaming
Yep.
growing up, and I was really into graphics. So I like to study graphics. I like to, you know, mess with 3D engines, write ray tracers, and I actually worked for NVIDIA as my first job out of
Nice.
college.
Nice.
So
That's
I was
awesome.
definitely in the graphics space. And then I wanted to kind of move into like the 3D app space, and Iman hired me for a great opportunity there. And as we produced apps, you do see the patterns inside of the front end kind of crop up in similar, you see similar patterns across multiple apps.
Yep. Yep.
You have patterns like MVC and that are
Model view,
very
whatever. Call it
modern
whatever you.
controller. Exactly. You have
Yeah.
certain patterns that aren't really well applied to game engines because of the update loop.
Yep.
And so um, what I was kind of looking at how React Native makes web development so easy and reactive, and
Yep.
thought I want game engine development to be as easy and as reactive.
Yep.
I notice a lot of engineers kind of by default in games try to push data into the 3D world. They try to
Right.
push data into the UI rather than having the UI react to data changes. And so I was really, really interested in figuring out, like, how do you solve that problem in a gaming engine in Unity? And we came up with a really, really great, really easy to use solution um, to make the UI reactive to data, to make the 3D world reactive to data. And then we have, on top of that, we have a great solution to sync data between the back end with
Yep.
server objects
Yep.
and on the front end. And so you basically have an entire data pipe that goes from all the way on the back end server all the way right up to the UI that's fully reactive.
That's sick.
And it really saves you a lot of code. It makes kind of using good architectures really easy. It makes
Yeah,
it really easy.
that's interesting because like I see a lot of the same problems even often in mobile app development where like a lot of those same patterns aren't applied or applied well, and also you run into this problem. So like the interesting part of combining reactive data with a server authoritative framework, and that'll be the next question, Iman. What does server authoritative mean to you? But like,
Okay.
but like combining those two worlds, what's really cool is like you get the best of everything, right? Because it's like you can drive the UI through data, right, and responses to changes in the data, but you also get like a persistent data model that doesn't disappear or like get destroyed when the client loses connectivity or drops off the game or whatever, which has solves a whole category of other problems that we deal with, right? With occasionally connected clients. So like combining those two things together seems like the best of everything, in my opinion. But anyway, so Amon, to you, what does server authoritative mean to you?
Great question. I feel like it means that the client can't override a value. You know, it has to kind of play by the rules of the game,
Yep.
right? Like the rules that the UI wants the player to play by. The the system you build makes sure that the client is playing by those same rules. So if somebody is not using your UI, they happen to be using some kind of network sniffer and pushing up arbitrary traffic, they don't get any type of advantage.
Nice, nice. Okay, I love it. I love it. And so with the game plumbing framework, what state is it in today? Is it considered a beta or fully released V1 or V2? Like where are you guys at with it?
It's. I think that's a great question. We've had a customer. Where our customer is a company called UX Magician, one of the top UX companies, and they use this with one of their customers, which we're under NDA. We can't talk about, but major telecom. Um, some really really exciting, interesting software, and so we have put it through its paces. We did that project. We probably did about. Uh, 2 years of development in 4 months as far as the product we were able to build for them. So we feel very confident about, you know, is it production ready?
Yep.
Um, as a company, our next phase is kind of this, fundraise and then hire because we want enough engineers to actually support, you know, being able to support multiple customers, right? So if I
Yep.
said, "Hey, it's ready right now," everybody would download it, and then Dan and I would be really busy. And what I prefer to do is hire up and then be able to kind of wave that flag. But from a tech perspective, I think it's 100% ready to go. It's
Sweet.
completely vetted. Yeah.
Sweet. All right. So I'm going to cut in here with some graphics on the architecture, but I want to talk briefly about my perception of the architecture, and you guys can kind of correct me where I'm wrong. But like, the first things I noticed is that it was super easy to get there's an AWS stack that's backing all of this, and that's where all the server authoritative stuff is living, and all the communication and data persistence and data streaming, and that was actually you've clearly done your work on getting a reference architecture that's easily deployable through CloudFormation or whatever automation you're using in the background. I just used your GUI and spun it up. I provided my AWS credentials, and that is spun up. But I believe you also have a way to do that through like CI/CD, or if you want to do it through automation, you don't have to go through the Unity front end in order to do
Yeah.
that. Yep, cool. And so you have this beautiful AWS architecture, and then within Unity, you have created your own like sort of client-side gaming objects that know natively how to speak to this backend, right? That's sort of my perception of it, and within Unity, you can extend the behaviors of those objects in your games, and like you can write, scenes or whatever that take advantage of those behaviors through. I don't know if it's through extension, if it's an object-oriented language, or if it's composition, or how you do it, but
Hmm.
So, a little bit of a correction.
okay,
Our server objects are just C# classes, so you can extend them with any class.
awesome.
It doesn't have to be a game object.
Okay, cool,
Uh,
cool. So
and
you're not opinionated about what front end is communicating with that thing then.
no.
Oh, that's awesome. Yeah, that has a
And
lot of applications, dude.
it,
Yeah,
and also our AWS architecture is for development environments. But
nice.
when somebody wants to go deploy this, they could deploy to Azure,
Oh,
for
that's awesome.
example. Yeah, so we don't.
Right, you're all container based then. Like all
Yeah,
your
we're
workloads are.
completely.
Oh, that's
Yep,
awesome.
100%.
Awesome. Awesome. Has anyone talked to you guys about using different gaming engines to work with it yet, or like have you experimented with
There,
it?
there's a lot of interest around us getting spun up on Unreal. Um,
Nice.
but it's work, so we kind of categorize that. Like we like to do things that are like people want it and it's simple, right?
Yep.
And that kind of goes into the people want it, but it's not simple category. So I think there will be a time where we go after that.
Awesome. Awesome. At my work, I mean, we've identified it just even for being able to power like chat applications or live,
Hmm.
tutoring or education sessions. Because a lot of the work you guys have tackled are it already deals with the problems you have when you're trying to connect multiple people and they want to send messages, whatever those messages are, right? You want to send a data stream, connect two people. Um, so let's talk roadmap. Are you thinking about WebRTC? Are you thinking about video? Like where's that going?
Yeah, I mean, definitely, we want to go after WebRTC. Um, I think, yeah, I think we need WebRTC in order to get the performance we want in a browser. We're getting really good, performance on, with the native Unity export and on desktop. But yeah, so we are big fans of WebRTC. Have also a lot of previous experience. In particular, Dan has written some amazing WebRTC uh, apps. So something that we kind of have a good grasp around what we want to do there.
And Dan, like what kind of games can you build on it? Like I've only seen the rock paper scissors games, but I'm just like curious as to like what can you build on it?
Yeah, so obviously it's easy to start simple, but the back end is really high performance, and so we have built a prototype first-person shooter.
Nice.
It can handle a very high tick rate, so it's not an issue if you want to have both a high performance and persistent world, and if you combine those two, then you have kind of like an action MMORPG. And so really we want to say you can build anything you want, because the architecture scales both like in speed and width. So uh,
Sick.
the sky's the limit. Yeah.
That's
Yeah, and
awesome.
I would just add to that, what we do or what we're really good at is keeping UI in sync with cloud data. Like we
Yep.
think about game data as this thing that lives on the cloud, and our job is to keep it all in sync. So as long as you have a game or an app that needs to do this, then our technology will provide a massive simplification in the tech stack.
That's a great transition into data because that's where the Foundry world meets
Hmm.
this, right? So like
Hmm.
my experience is like let's peel back the layers of the onion of data analytics right now because like my experience with analytics is like you get yet another SDK syndrome where it's like for every single one of these things that we want to track, we end up getting these embedded SDKs, whether it's like for amplitude or heap.io or for like mParticle. And so we're being, or Google Analytics, God forbid, but like for every one of these telemetry systems, we end up embedding these SDKs, and you wind up with these fragmented kind of data silos where you have like marketing people not talking to the product people, not talking to the engineers, and
Yeah.
really what we want is a unified data landscape where like we don't
Hmm.
have third parties messing with our data. Like we want to take our data
Hmm.
first party. We don't want to
Hmm.
embed those SDKs because what I've found with the SDKs is they're super intrusive. They end up screwing up like we don't know what they're introducing as a dependency for the most part, and
Yeah.
so we don't know what that, and it also degrades the experience for our users, and then we don't truly own our data. We're sharing our
Hmm.
data with people,
Hmm.
right? So like what are your guys' thoughts? Iman, let's start with you and then we'll go to Daniel.
Sure. Yeah, I think analytics often with games is an afterthought. You want to find the fun first, but then once you get live, if you don't have a strong analytics capability, you're dead in the water. Like you need to be able to iterate to make sense of data. And I think the biggest challenge there, exactly what you said, like this idea of like these siloed departments. Game developers are asked to like just track everything, right? They don't know how this data is going to be used, and then um, the people that do the analysis are like, hey, just do the best with the data you have. So I think those are major issues. Other issues include exactly what you said. SDK hell. Usually these SDKs don't even play well with each other,
Yep.
so you have to go and get the right version of this and to talk to that. So I think, yeah, in general analytics, there's a big opportunity there. In general, it puts a lot of pressure on game teams, and in general it takes them a very long time before they do a good job executing and being able to do good analysis. So I
Cool.
completely agree. Mhm.
What are your thoughts, Dan?
I mean, they're very similar. I think you guys did a great job covering it, especially the SDK integration problem
Yeah.
when it comes to analytics, maybe advertiser networks, and the people who uh, who need to who are responsible essentially for the performance of the marketing want things to go into the game, and then the people who are responsible for the performance of like the playability of the game
Yep.
need a completely different analytics solution
Exactly.
from the marketing. And
Exactly.
yeah, it does create kind of this, either you're doubling up messages, that happens all the time,
Yep.
or yeah, you have a gap, and that's
Yeah.
both are bad.
And so,
Yeah.
and go ahead. Go ahead.
Well, I just don't like the idea of my client sending like messages to an endpoint that anybody can see, and then they can send messages to that
Yeah.
endpoint. Like if I'm
Yeah. Yeah.
competing with you, why don't I just mess up your data? It's
Yeah.
super simple,
Yeah.
So what I like about what we were able to do with this prototype is the front end never had to integrate with anything,
Exactly.
right? Everything's server auth.
Yep.
Nobody knows the endpoint that we're talking to.
100%.
Yeah, so it's
Exactly.
clean. You can actually rely on that data, right?
Exactly. It's super
Yeah.
clean. And then, like, and in response to this too, there's, Google Analytics, the pro version starts at 150 grand a year. Other
Hmm.
services, when you're under heavy load, are a minimum of like anywhere from 300 to $500,000 a year. And so it's like
Hmm.
when you're stacking all these things on top of there, you're getting to like near $1 million spend on all the various analytics tools that you're using and your AWS bill on top of it, right? So like, because eventually you want to get all this data into other tools you're analyzing inside your data lakes and everything else. So it's like
Hmm. Hmm.
it,
Hmm.
it leads to all kinds of problems. But let's talk about the kind of decisions. Dan, you made a great point. Like the types of decisions people want to make. There are different types of decisions that need to be made. That the engineers are worried about what you talked about, which is playability and latency and like security. And then there's people on the marketing side and the product side. They're more worried about engagement and like which version of the game is getting better retention and engagement with your
Hmm.
users and where there are more in-app purchases. But like Iman, let's start with you. Like I know you have some experiences being at
Yeah.
Disney before, but tell us the kind of decisions that need to be made in there.
Sure. I mean, yeah, we can categorize them. Engineering is very concerned about uptime,
Yep.
right? So I want to make sure that, if I expect a certain amount of traffic, that's the traffic I'm getting, and I want it segmented by regions, right? Because, we might have like some bad data on an S3 bucket somewhere in a particular region, and that would be good for me to know if like a region goes down. So yeah, first and foremost, I just want to see that people are like, they're doing that first game action, and at quantities that I expect, right? I expect like at any given geolocation in the afternoon at 3 p.m., we're going to see a lot of data. At 3 a.m., we're not going to see that much data. So if I can see those things, then I know, that's a good way of telling me that my system is up globally, because I can always check to see if it's up where I'm at, but that's not hard, right? The hard thing is to know that it's up globally. Then from a product standpoint, if I launch a game, the first thing I want to see is that users can get through that first 5 minutes and look at drop offs, right? Like,
Yep.
what was the last thing you did before you dropped off? Because I think that this is, you might spend a month iterating on just your first 5 minutes, and just getting rid of those drop offs, because generally this is when users are learning the game. They're figuring out if you met the promise of your ad is promising something. If you don't give them what you promised, they're going to drop off. If you have a complicated game and you're not really teaching it, the game team has this bias because they get paid to work on this game. They know exactly how to play it, whereas just the user out of nowhere, they don't have that bias. So that first 5 minute drop off, and then eventually you go into a retention, engagement, playtime, back to drop offs. You have all of your funnels, and once you have all of those, now you come down to monetization, right?
Yep.
So it's really healthy to kind of think about it as like a pyramid, like a hierarchy of needs. Like, if your monetization is broken, it's probably because something is broken before that, right? Like if your system is down, it doesn't matter how good your game mechanics are, right? So yeah, thinking of it as a hierarchy of needs, being able to say, okay, monetization is broken today. Is that a technical issue? Did we bring in a new feature with some drop off? Yeah, you want to be able to do all that. And then separately, you want to do A/B testing.
Yep.
You want to, so you want to do multivariant, right? You want to be able to run lots and lots of tests. In my experience, this can make a big difference. And me personally, my bias is for predictive lifetime value. Being able to just correlate it to the number you really care about, which is how much money you're going to make off of each user over the course of their lifetime.
Yep, and that's a good segue, Dan, into something I wanted to ask you too about the A/B testing. This is something we struggle with a lot, even on the React side, like at my work, and like we're trying to automate the A/B testing scenarios because like a lot of developer work goes into just making sure that there's like we actually normalize to a variant at the end of the test because sometimes we forget, so the engineers like actually forget to normalize to a variant. But then it's like making sure the code stays up to date and it's actually windowed correctly with the product team so we don't skew the data. It's all, all of that human interaction as an experiment is taking place. It's kind of sucks. And so like we want to move to a fully automated model. But what's your opinion on like how you could actually drive automation in the front end with these variants? Like, what do you think would be a clean architecture if you said, if product person over here is using this dashboard in Foundry and says, okay, variant ABC is the best, let's use that one. Do you think that's possible to be able to update the game, and what do you think?
Yeah, absolutely. So, um, you know, our backend has the ability to, talk to other servers, talk
Yep.
to other things on the internet, but also, have data pushed in securely. So
Yep.
it would be possible for um, a game designer, game manager to be able to maybe start collapsing A/B tests in real time on the actual product that's in production, um, if they're seeing the data support that test.
Nice.
So yeah, the back end is very again able to be changed, and because things like and again because we make sure that the app is very reactive and will react to any changes on the back end, people will see those changes immediately, and as they occur there won't be any sort of disconnect in the server thinks one thing and the app thinks another, because
That's
that just
insane.
can't happen.
Yeah.
So you are going to be able to completely, again, yeah, move people from one test category to another in order to optimize.
Nice.
Just to add some color there, I'm a big advocate of something I call extreme data driving, which is where you have this Google spreadsheet, and you can almost like coding within that spreadsheet. You can drive the behavior of your app, right? So you can set up a brand new user flow, right? Because
Nice.
you have like you've created this little language that lives in the spreadsheet, and product people are, they can get in there, and you have all the
It's a
validation set
familiar
up.
interface. Yeah.
Yeah,
Yeah.
and so once you do that, now now an A/B test variant is a patch, right? It's a data patch,
Yep.
and so it's not an if statement in code, right? It's not something that you got to release a new build for. It just is a patch of data that if we're in this variant, we're using this patch. And if we're in this other variant, we're using this other patch. And so once you have that set up, you can go into Foundry, some dashboard. You can look at the statistics associated with each variant, and you can flip one of them on. And the really cool thing about this is you can run, as many as you could run 30 A/B tests with, 3, 4 variants each,
Yep.
as long as they don't override the same cell.
Yep.
It's all orthogonal, so it all works. Yeah.
Yeah, I think you have options in Foundry too. Like Foundry does have Fusion, which is like a spreadsheet interface, so you could actually drive
Oh,
this
cool.
inside there on a spreadsheet
That better,
interface.
even better,
Yeah,
right?
yeah,
Yeah.
yeah, exactly. So
That
you don't have
sounds
to.
that sounds super exciting.
It's cool.
So
Yeah,
I'd like to explore that, right? I'd,
yeah.
I'd like to try to get this stuff set up with the spreadsheet.
Sick. All right. So that'll
Yeah.
be, but yeah, so in this first iteration, we're going to try and keep it pretty simple. But I think as we evolve it, we'll try to maybe get to the point where we're driving code changes. But the other thing that I really love about your architecture is that you could actually deliver this like as a uh, like platform as a service on AWS, where you offer it through the marketplace. You have your stack that you're going to spin up. You could have Foundry stack that you're going to spin up, and then you could
Yeah.
have the templates for Foundry that have all of the analytics capabilities, all of the spreadsheet interfaces for driving the product decisions, and anything else if you decided to build inside their GUI tools, all in one PaaS platform for AWS. And you just hit the build button on AWS, assuming you have the money to buy Foundry, which a lot of people don't have the money to buy Foundry. But that is the future to me as the price point comes down and more people get into the platform. You know, especially for gaming companies who are looking to maybe take that next step, or maybe you're trying to launch a new gaming company. But to me, I see that as kind of the future, where you could just get this whole stack integrated, and then all of a sudden you're building games. Your engineers worry about the gaming aspects. Your product people worry about the product aspects. But all of your data is first party and owned, and you have this like awesome sort of user experience. So it's gonna be.
No, I love it.
Yeah,
that sounds awesome.
And by extension, that's where I would love to see the Foundry analytics space go. And I kind of think they see that coming. Like I think they have this idea of a marketplace, and I think they have identified data analytics as one of those markets that's primed for disruption for all the reasons we just talked about, like the SDK problems, the cost problems, the various problems with different teams making different decisions off the data. They all need one platform in which to do all that. So I think Palantir has like identified that as a space they're going into or going to go after. That's just me speaking. Like, it's not Palantir talking, but it's my intuition anyway as to where I see things going. All right, guys. Well, thank you so much for your time today. I'm going to go ahead and get this up on the channel, and hopefully we'll start unveiling some code soon, and people can start seeing this thing take shape. So thank you, guys.
Thank you, Dorian.
Talk to you. All right, so there you have it, the game plumbing framework and how we're going to incorporate it into Foundry for gaming. I love this architecture. I love this framework. I love the fact that there is no third party touching the data that's coming out of the game plumbing framework, and the fact that it's a server authoritative framework means I don't have to put any client-side data streaming in there. All of the data streaming is going direct from the server in a secure environment into Foundry, which is critical, and a lot of applications can't leverage that. Beyond that, there's lots of applications for the game plumbing framework to power a lot of other types of applications, including chat, including video, including audio streaming. So I'm excited about this beyond gaming, but what it means for Foundry and Foundry customers is incredible when you start thinking about all of the other tools that are out there that are producing data for companies, and how they could ultimately, instead of streaming those into third-party services like Google Analytics, stream them directly into Foundry to take full advantage of the data processing, analytics, and ontology system, and then build all your engines with no-code solutions, right? Like, why can't the VP of marketing build themselves the perfect dashboard with all the features they want using a tool like Contour or using a tool like Workshop, where they can build full-blown applications that actually do things, right, that actually ship and deliver business value directly. That is going to be ultimately what we end up showcasing in subsequent videos. So get ready, people. Foundry for Gaming Part 2.